This is an intro to linear approximation. Linear approximation can be used to estimate the value of a function using the point of tangency. And so by using the tangent line, we can estimate the value which the question is asking us to find. And so this is usually done using derivatives and finding the derivative of the function given to us. And so regarding questions, more or less the question will be phrased like this. A function will be given to you, and a tangent line at some value of x will also be given to you. And we will need to find or approximate the value of f at some value of x. And so in this case, the function given to us is f of x equals x squared. And the tangent line is at x equals 1. And what we need to approximate is f at 1.1, or f at x equals 1.1. And so whenever a question asks you to use the tangent line to approximate some value of f, it will usually be asking you to use linear approximation. And so when a question asks you to use linear approximation, it's important to understand what formula we need to use. And so the formula we need to use for linear approximation goes something like this. L of x equals f of a plus f prime of a times x minus a. And so this is the only formula you will need to know if a question asks you to use linear approximation. And so in this formula, x is just x, and so that's x, and the function f is given to us, f of x, and a is always the constant given to us. So in this case, the constant given to us is 1. And so what a actually is the tangent line at the value of x. So regarding this problem, the value of x at the tangent line is 1, right? And so that means the value of a is 1. And so now we can fill out and replace a with 1, and we get f prime 1 times x minus 1. Now that we've plugged in 1 for a, we can now plug in the value for x. And so the value for x is always what are you trying to approximate. So in this case, we're trying to approximate f at x equals 1.1. So the value of x will always be what we're approximating for. And so in this case, we're approximating 1.1. So we can replace x with 1.1. And everything else remains the same. F prime 1 times 1.1 minus 1. And so this is the equation we get, right? All we need to do now is plug in our values for the function. So L, the function L is what we're looking for. So we can't plug in 1.1 into L because that won't give us an answer. Instead, we'll plug in 1 into the function f. So f of 1. Since the function f is given to us, we can just plug in 1 into this function. So this will be f of 1. 1 squared is 1. So that will be 1. Now, f prime of 1. To find f prime of 1, we need to first find f prime of x. And so to find f prime of x, all we need to do is find the derivative. And I'll do that here. Finding the derivative of f prime of x, we can simply use the power rule, and we get 2x, right? Using the power rule, x squared becomes 2x after we take the derivative. And that means f prime of 1 equals to 2 times 1, which is 2. And so this is f prime of 1, 2. So you can replace f prime of 1 with 2. Now all we need to do is subtract 1.1 and 1, and we get 0.1, and plug in this part, and our value is simply 1 plus 2, or 2 times 0.1 actually, 2 times 0.1, which is 0.2, plus 1, which is 1.2, using PEMDAS. So we multiply first and then add 1. And so this is what we get, right? And so this is the approximate of f at x equals 1.1. So in this question, the function given to us is f of x equals natural log of x, and the tangent line is at x equals 2. And what we're approximating is f at x equals 2.2. Now, like always, we'll start with the formula, which is L of x equals f of a plus f prime of a times x minus a. Now I'm going to plug in x and a at the same time, and I'll get L of 2.2. It's 2.2 because x, remember, is what we're trying to approximate, f of 2.2. So 2.2 is our x value. And now a is the tangent line at what value of x? So the value of x given to us is 2. So f of 2 plus f prime of 2 times x minus a. X is 2.2 minus a is 2. So we get 2.2 minus 2. All we need to do now is plug in 2 into natural log of x. And you can use a calculator for this, because the natural log of s, or natural log of 2, is not easy. You can't do that in your head. So that is equal to approximately 0.693. Right? And now all we need to do is find f prime at 2. Now to find f prime at 2, we need to take the derivative of the function given to us. So the derivative of f prime of x is this, natural log of x. That is equal to 1 over x. That's an identity or a formula you must know. The derivative of natural log of x is always 1 over x. Now when we plug in 2, because f prime of 2, we get 1 over 2. So we can write that here. Multiply that by 2.2 minus 2, which is 0.2. And that is all we have to plug in. Now all we need to do is solve. So we can do 0.5 times 0.2, which is 0.1, plus 0.693, which is 0.793. And so this is our approximate. All we did was make the formula. Remember the formula. This is the key step, remembering the formula. And so after we got the formula, half of our work is done. Now all we need to do is plug in the value of a and x and take the derivative to find f prime. And then all we need to do is solve. So in this problem, we have the function f of x equals e to the power of x, the tangent line at x equals 0 to approximate 0.1. So we can write our formula, which is L of x equals f of a plus f prime of a times x minus a. Now we can plug everything in. X, what we're approximating, is 0.1. A, the constant, the value of x, at the tangent line is 0, so f of 0 plus f prime at 0 times x, which is 0.1, minus a, which is 0. Now we can plug in 0 into e to the power of x, and e to the power of 0, which is 1, plus f prime at 0. For that, we need to first find the derivative to find f prime. And the derivative of e to the power of x is e to the power of x, right? So f prime of x equals e to the power of x. That's just an identity you need to know. And f prime at 0 is simply 1, because e to the power of 0 is 1. So you get 1 plus 1 times 0.1 minus 0 is 0.1. So when we solve this, we get 1 plus 1 times 0.1. In other words, 1 plus 0.1, which is 1.01. And so this is the value which is what we were asked to approximate, f at 0.1. And so after you do all of this, there is a way to double check your answer, and that is to simply plug this value into the function of f. And so if you plug in f at 0.1, you get e to the power of 0.1, right? And so it's not that easy to find the value of e to the power of 0.1, because you will need to use a calculator for that. And so when you end up using the calculator, you get something, or you get the approximation of 1.105. 170918. And so if you compare these two values, they're pretty similar. 1.1, in this case is 1.11, and in this case is 1.01. Oh, actually, here, this is 1.1, my bad. And so 1 plus 0.1 is 1.1, not 1.01. And so these two values are pretty similar. And so if you want to double check your answer, all you need to do is plug in this value into the value given to you, or into the function given to you. So e to the power of 0.1 is 1.1 approximately. So in this question, we have the function f of x equals square root of x, and the tangent line is at x equals 4, and we need to approximate f at x equals 4.1. And so since you know it's linear approximation, we can simply write our formula down. L of x equals f of a plus f prime of a times x minus a. Now in this case, x, what we're approximating, is 4.1. So you plug in 4.1 for x, and a is our value of x at the tangent line, which is 4 in this case. So f prime 4 times x, which is 4.1, minus a, which is 4. Now we can simply solve this, and we get f at 4 is the square root of 4, which is 2. And f prime at 4, to find that, we need to take the derivative to find f prime. F prime of x is equal to, if you take the power rule, if you use the power rule for this function, you get, first we can write it in this form, and this becomes 1 over 2 square root of x. This is f prime of x. And f prime of 4 will be 1 over 2 times square root of 4, which is 2. 1 over 4. And we can replace this into our formula. Multiply it by 4.1 minus 4 is 0.1. And our final answer, it's simply 1 over 4 times 0.1 plus 2. So 2 plus 0.025, or 2.025. So this is our approximation for f at x equals 4.1. And just to double check our answer, we can plug 4.1 into the function given to us and use our calculator. So the square root of 4.1, if you have a calculator, you can approximate that, and what I get is something along the lines of 2.02484567. And so it's almost the same value. It's 2.025. When you round this out to 3 decimal places, you will get 2.025. And so basically linear approximation is used to approximate a value of the function given to you when you don't have a calculator. So we did all of this work and we didn't need to use a calculator to approximate f at x equals 4.1. At the end, if we somehow managed to acquire a calculator, we could double check our answer, and we found out that it's really similar, both the answers. So here we have given f of x equals cosine x, using the tangent line at x equals 0, approximate f of 0.2. So for this, we can simply, again, start with our formula, which is L of x equals f of a plus f prime of a times x minus a. And now plugging in our values, x, which is what we're approximating, in this case it's 0.2, plug that in, and a, which is the value of x at the tangent line, that is 0 in this case, f prime of 0 times x, which is 0.2, a, which is 0. And now all we need to do is solve this equation. So we get 0.2 equals f of 0. Plugging in 0 into cosine, we get 1. Cosine of 0 is 1. And f prime, to find f prime, we need to find the derivative. And to find the derivative, all we need to do is use this function. So f prime of x is equal to, and the derivative of cosine x is negative sine x. Alright, and so negative sine x becomes f prime of x. And now we can plug in 0, so f prime at 0. The sine of 0 is 0, and so negative 0 is 0. So f prime at 0 is 0. Times 0.2 minus 0, which is 0.2. And so what we get is 1 plus 0 times 0.2. So 0 times 0.2 is 0. 1 plus 0 is 1. And so our approximation is 1. Now we can double check our answer by plugging in 0.2 into cosine of x. Cosine of 0.2, using a calculator is 0.98. And so 0.98 is pretty similar to 1, which is our approximation. And so we can use linear approximation to approximate any value of the function, original function f, without using a calculator. But the problem is the value given to us needs to be close to the value of x at the tangent line. So if you noticed, each of these questions asks us to approximate a value of x which is close to the value of x at the tangent line. And so in this case it was 0.2 and 0, and so the difference was 0.2. And so the difference will rarely exceed 0.5 or 1, the difference between these two values. And so whenever the difference between these two x values are less than 1, you can use linear approximation.